Hey everybody, this is Ian Griffin with Nyle Dry Kilns, and today we're going to talk about some of the different types of sensors that we have in our various small and large kilns. What's kind of the difference between an electronic sensor versus a traditional dry bulb wet bulb, and just kind of what's going on with these things. So first things first, we're going to go over the old reliable, the RTD. It is a, oh, I should know this, a resistance temperature detector, I believe is the acronym, if I remember correctly. And basically what's going on here is it takes into account the idea that as the temperature of metal changes, the electrical resistance changes. So as it gets hotter in the kiln, you send a tiny little signal up here, and then the resistance is going to change, and how much of that signal comes back to the controller can be calculated into a temperature. So these are really, really reliable. They've been used in kilns for a really long time, and they go hand in hand with this wet bulb tray and wick over here. So we're gonna show it to you guys real quick. I don't know how close that is, but this is what you'll see in a lot of kilns. It's very, very common. And then this right here is a wet bulb tray and wick. So for your dry bulb, you would just hang this kind of in the kiln and it would measure your temperature. But if you want your wet bulb, your humidity reading, you would have to slide a little wet bulb wick on this guy, and it would end up sitting in there and it would get soaked with water. And as the water absorbs and it wicks up the wick, that cooling effect of evaporation is going to be what gives you your wet bulb reading. It's the same exact principle as when you're sweating and you cool your body off. So that's how a traditional dry bulb and wet bulb work. The downside to one of these is obviously you have a tray full of water that has to have actual standing water in the kiln chamber. So you have to worry about it drying out. You have to worry about it freezing over and bursting pipes in the winter. And there's definitely some headaches that can be associated with that. One of the biggest things I recommend to people that have these is you want to make sure your wick is mounted as close to the water surface as possible. If you've got a tray like this, you would probably have, rather than a little shoestring wick like this guy, it would be a wider sock that would sit down into the water. And you would want to make sure it's close enough that even if the conditions in the kiln get dry, it doesn't dry the wick out. Because if your wick dries out, it starts functioning like a dry bulb. And if your vents or your dehumidification compressor all function based off of your wet bulb, if you get a high reading on it, it's going to tell your vents to open or your compressor to turn on. So it's really, really critical that that doesn't dry out, because you could end up with a kind of snake eating its own tail effect where the conditions in the kiln are dry, and then you turn on your compressor or you vent and it gets more and more dry, and the wet bulb wick dries out more and more, and your equipment kind of never stops, and you end up with a very harsh environment very, very easily. So these are really reliable, and they work really, really well. The downside is the complications that come with the actual wet bulb tray itself. So one of the things we've started doing as a company is switching to a lot of electronic sensors in a lot of our kilns. We still have these, we can still procure them, and if a customer wants them, we'll still install them. But we're transitioning primarily to the electronic sensors to get rid of a lot of the headaches associated with this guy. So we're going to look at the first one here. This one is called an E+E 72. So you'll see this in a lot of our small kilns. You don't really need that little sticker on it anymore. And you may find, if you have an older L series unit, you may have a different type of electronic probe. We had one that was called I think a DF robot, and then we had an E+E 71, which is the precursor to this one. It was a little shorter. If any of those fail, or if you buy a newer L200 series, it will come with these ones. We don't use the other ones anymore. We don't support them. If they fail, we just replace them with one of these. So what's going on here is this is a temperature sensor that functions similarly to an RTD, but then it also has a relative humidity sensor in it as well. So that will calculate a wet bulb based on those two values. At the end of the day, your dry bulb and your wet bulb, your relative humidity, EMC, all that kind of stuff, it all has a corresponding number. If you have a set dry bulb and a wet bulb parameter, it's going to have an equivalent relative humidity. So because of those values, we can use a relative humidity sensor and give you a calculated wet bulb on your controller. So this is really common in our smaller units nowadays. And then this guy right here is a bit of a bigger one. I'm going to try not to drop it. This is a Comet sensor. and it functions exactly the same way as the E+E sensor. It's just this is what we would typically use on our larger kilns or retrofits. If we end up swapping our controls onto a pre-existing kiln, they will get these a lot. And what ends up happening, for those who don't know, you always get a sensor on the front and the back of any kiln with reversible fans. But if you've got a small kiln and reversible fans aren't necessary, you might only get the one on the entering side. Super important, you always want to control the entering side of the air on any kiln charge, just because if you control the exiting side, as the air gets cooled off, picking up all that moisture, and the temperature drops, if you try to heat to a set temperature on the exiting side, your entering side is going to spike because your heat's going to be, running full blast, and you're going to be way higher temperature on the entering side than you want. So you always control off the entering side and then accept the cooler side as it picks up the water. In reversible fans, it'll alternate which controller, which sensor you're reading off of when your fans swap. But on non-reversible, it doesn't. It's not relevant. You've only got the one because you're only controlling off the one side. So that's kind of a quick rough overview of the different sensors we utilize here and kind of what their strengths and weaknesses are. Hopefully that wasn't too complicated and I did an all right job. And if you have any questions, feel free to reach out to us. Our phone number is 800-777-6953. Thank you.